All right, hello, my wonderful students. This is folder number 1 for 7.3, writing an exponential logarithm, logarithmic function. So we're just going to kind of go over on the first one, we're going to kind of go over the basics of how it works. So, let me make an adjustment real quick. There we go. And that's about right. All right, so for this one here, we're just going to kind of, like I said, just go over the basic form of what we're going to be looking at. And I wrote it twice because the first time I wrote it as just one color, and then I realized we should kind of write the different variables that we're going to be moving in different colors. So we have the y is equal to the log of b to the x, and that in turn ends up being x is equal to b to the y power. So this is the form we have here. We have the 100 is equal to 10 to the x, and we have to write this one in logarithmic form. And then we have the ones down below that we're going to go the other way around. Okay, so first thing we're going to do is we're going to take each of the variables, or each of the numbers, and we're going to write it according to this here. So we have our x here for this one, which is in green. So we're going to write 100 in green. And this is going to be equal to our 10, which is our b. So we're going to write it in blue. And we have our y, which is in red, which is our 2. So now we have this formed here in the same colors. So now we can go ahead and rewrite this here. Okay, so we're going to do that. Start with our red. Oh, it's already selected. I was looking for it. Okay, so that's going to be R2. And then we have equal to the log of base b, which is our 10 here. Log base 10 is also our normal logarithmic power. So if we don't have a number down here, it's usually going to be log base 10. And then we have our x, which is in green, 100 there. So this is how we would write the logarithmic form of this. 100 is equal to 10 squared would be the logarithmic is equal to 2 is equal to log base 10 of 100. And you can see that because if you see 10 squared equals 100. Next one, we have 81 is equal to 3 to the 4th power. So once again, we're going to rewrite everything according to this formula here, and then we're going to convert it over to logarithm. So we have our first one is our 81, which ends up being our x. We're going to set that equal to. And then we have our 3, which is our b, so it's going to be blue. And then our y is going to be to the 4th power, because that's our y there in red. All right, once again, we're going to rewrite this according to this equation here. So we have our y, which is red. And then we have is equal to the log of 3. So it's our base. 81. Oh, I just realized I put, hold on, 81. And I just realized I put y here, but it's actually supposed to be R4. I know it kind of looks like y, but no, it's 4 is equal to this. And we can see that because it's 3 to the 4th power is equal to 81. Really quick before I finish, I wanted to give you guys the definition of logarithm because I figured this is the first time we're seeing it. So we're actually going to define logarithm here. So it's going to be a logarithm. And the definition is, so it's a quantity representing the power to which a fixed number, and that usually fixed number is this one here, which is usually, I guess we can write the base because it is the base. The base must be raised to produce a given number. Number. Basically, that just means if you have this here, so a quantity representing the power. So I know this is here, right? Representing the power. quantity. So we're saying this is going to equal this, but this is the power of the base. It's the power to the, which is the fixed number, the base. So the fixed number is going to be our b. Usually so that's always going to be given. So that's our b that's here. Always going to be, so the log of that number must be raised to produce a given number. So it must be raised to produce number here. So when we get this equation here, basically most of the time, like always, we're trying to solve for y. So we have the base and we have what it's equal to after. So we have the base and what it's equal to after. And we're trying to solve using the log of what the power would be in order to get that base. That's basically what this is all about.